Okay, here are some guidelines for solving exponential equations. So when it is not possible to rewrite each power using the same base, then we need to use a different technique, and that technique involves logarithms. So to solve an exponential equation with only one term on each side of the equation, so just like we saw in the previous example, so if you had something like 7 to the exponent x equals 400, first of all, we know that we can't write both of these using the same base, so that eliminates what we did yesterday. And so the technique we're going to use is logarithms. Okay? One term on each side of the equation means there's one term on the left and one term on the right. When you have something like that, then you can take the common logarithm of both sides of the equation and then apply the power law of logarithms. What that will do is help you bring the exponent as a coefficient instead. So that'll bring the variable part out of the exponent part of the equation, and then you can just solve for the unknown variable from there. So let's take a look at some examples. So for this one, it says solve each equation and leave answers in exact form. So what that means is we won't be using our calculator to help us evaluate this. So in the first one, you have 2 to the exponent x equals 3 to the exponent x minus 1. And you'll notice that there's no way I can change a base of 3 to make it a base of 2 and vice versa. So the only thing I can really do here is take the logarithm of both sides. And I know I can do that because there's a single term on the left and a single term on the right-hand side as well. So let's start by taking the logarithm of both sides. Okay, and now I can use the power law of logarithms to bring down the exponent part as the coefficient of the logarithm instead. Okay, so what I get on the left-hand side is x log of 2 equals, and I'll put this in brackets, x minus 1 since the exponent part has more than one term. So x minus 1 times the log of 3. And now what I'm going to try to do is try to isolate the variable. Now, on the left-hand side, it's already in expanded form, but on the right-hand side, it's not in expanded form yet. So what I'll do is rearrange that so that it's actually in expanded form. So I'll multiply out the x minus 1 with the log of 3. So I did x times log of 3 minus 1 times the log of 3. And now what I want to try to do is, I'm trying to solve for the variable x. So I'll get the x terms on one side of the equation and then the terms that do not have any variable parts to them on the other side of the equation. Okay? So what I'll do is I'll move the negative log of 3 to the left-hand side by adding it to both sides. And I'll move the x log of 2 to the right-hand side by subtracting it from both sides. And so what I end up getting is the log of 3 equals x log of 3 minus x log of 2. Okay, so now I have the two terms that have the variable with them on the right-hand side. And now I can factor it out. It's a common factor from both terms on the right-hand side. So I'm going to factor it out on the right-hand side, and I get log of 3 equals x log of 3 minus log of 2. So I factored out an x from the first term and the second term since that was the variable I'm trying to solve for. And you'll notice that now I can isolate x by dividing both sides by the brackets that I have here, which is log of 3 minus log of 2. And so I end up getting x equals log of 3 divided by log of 3 minus the log of 2. So here's the exact value of x for the first question.